All right, welcome back. Let's discuss the different ways in which we can actually move through an array list. This is going to be a pretty quick video because I did sort of somewhat accidentally go through some of these already in my previous video. So feel free to pop back over to that one. That's why that one ended up a little bit longer. So the first way that we learned was the for loop. Just really quick, you'll notice that I already am bringing in my utility package with the ArrayList class, and I have my main and everything set up as always. Let's go ahead and just add our array list right here, array list, and let's get started with adding in a few elements. So I'm actually going to use a loop to add in just 10 elements, I guess, and each one can honestly just be list.add the value of I. We'll just turn it into a string like that. That works. You can also turn it into a string like this, string.value of. I showed you integer.value of the other day, the other video, I should say. This is the slightly more correct way of solving this problem as well. And then if we want to print it, I should probably have something to print out to prove to you what this is going to look like. All right, we'll do that, and let's run it. There we go. So we just really quickly threw together a loop in order to grab everything. Now, as we saw in the previous video, we can loop through our array using a for loop. However, the caveats of this include do not, well, I guess I should do it for the print. So let's do a one-line print method for the list. Let's do a for loop print for the list. Let's do a for each loop print for the list, and we're going to talk about the iterator print for our list. There we go. Those are the four things we're going over. Now, this first one, public static void one-line print for our array list, as we know, is just this. That's not new. We've already run that. That's not that exciting. Perfect. Let's go ahead and look at the for loop print next. This one, as we said, was going to be the one-line print. Now, because I'm practice what I do, what I say, not what I do, I'm going to copy paste here. I'm going to add this for loop print right here, change that right there. Let's go ahead and make our for loop right in here. Now, I will go ahead and do this using the size because I don't know at this point how big it is. And I could just print out each of my elements. In fact, I could even print it out in the same format as the one-liner. I can first do a print statement with an open bracket. I can then do a print statement on the element at spot I with this comma in there, just like the other one. Actually, what I should probably do is say if I is list.size is less than the list.size minus 1. So as long as we're not in the last element, then we can add this print of that right there. And at the end of all of it, we need to do our closing bracket. There we go. So now when I run this, we're going to print the one-line loop and the for loop print. Let's take a look. One-line print, there we go. For loop print, exact same format. Now, the main difference here for the for loop print, basically the caveats where we needed to understand that we shouldn't be doing modifications to the list when we're running a for loop, because we shouldn't need to change I inside of a for loop. We talked about this in the last video. We have size here. If size is changing as we're in the loop, whether that means adding or removing, we can run into a problem that can often be very tricky to track down. Let's look at our next option here, which is going to be our for each loop print. Now, a for each loop is really awesome. For each, loop is really awesome. I did use this in the previous video as well, where I would say for each element, let's say in the list, print it out. It's a little bit trickier to print it in the same format, just because we don't have access to an index counter anymore. So I can still add this bracket here, and I can still add the closing bracket on it over here and end with a new line. But we won't be able to put those commas in without having an extra comma at the end. We can't even put the spaces in without having an extra space at the end, right? There's that extra space. It's hanging out at the end there for the for each loop print. Now this is safer. This is safer than doing a for loop because you cannot edit a list, like an array list, inside a for each loop. You can try, but it actually will throw an exception. And this goes for adds or removes. So if I try to do a list.remove the element that I'm on as I try to, let's say, empty my list one by one, I'm going to get that error. Check for co-modification, right? Concurrent modification exception. So that's kind of a neat one that we haven't actually seen before, but that we are throwing. If I try to add, re-add another element to the list inside there, exact same error. So this is safer because it prevents your code from looking like it ran successfully when really something weird is happening to an array list internally. All right, the last one that we're looking at, the new one that we're looking at for right now, is this iterator print. So let's go ahead and uncomment it and let's pull this down. Iterator print, iterator print. Now, I told you that you would be able to basically write your own array list if you wanted to. You could take a partially filled array into a class, you could call it ArrayList2, and you could basically implement all the functions that we're talking about. You can implement a size, you can implement an add, you can do the dynamic resizing, you can implement the remove, you could implement your own array list. And honestly, I encourage it as a way to really understand what the heck is going on here. But there is one piece that we haven't talked about, which is this idea of an iterator. Now, if you noticed, you may not have, in that previous run, right here in this error message, we saw this ITR come up with that error, with that co-modification error. Iter.check for co-modification. That's because there is one little piece that I left out, which is internally within an array list, it isn't doing just a normal iteration through when it does things like .get. It doesn't just make its way through in a normal way. When it tries to do the printing, it actually does something with what's called an iterator. And we can extract that iterator and sort of use it in our own unique way if we needed to. And that's what I'm going to show you right now. All right, so iterators are safer ways to work our way through lists of data because that's all they do. That's their whole point. That's their job. So first of all, we needed to then import this iterator class. Okay, now we need to get the iterator from our array list. Iterator of strings, we'll just call it IT, is equal to, not a new iterator, sorry, list.iterator. And we can actually pull the iterator out. And what is this going to give us access to? Honestly, it looks a little bit like scanner. So we can do stuff like while it.hasNext. Let's print it out. it.next. And it's just like scanner. It will grab the next token, the next data element, and move to the next one. I'm going to add just that extra print, that extra print line here at the end, just for safekeeping. Compile, and there we go. Now, I didn't actually space them out. I didn't do anything nice with it, right? We saw that. But this would now actually give us the ability to more safely check if we're on the last element and put our commas in. If the iterator has a next element, system.out.print a comma. There we go. It will now print a comma on every single one except for the last one. Now if I add my open bracket there, I add my close bracket there, I rerun this, clear, I end up with exactly the right formatting that I could not get with a for each loop, but I still have the safety of the for each loop. So an iterator works similarly in that we can now be safe with how we're manipulating our data, but we also have the power of scanning ahead and figuring out where we are in our list to do things like format nicely and other things as well, of course. Now, this also gives us the ability to safely remove elements while we're running through our loop. We don't have to worry about the same issues we saw with a for loop. For example, let's go ahead and grab the element it.next that was in there and just print it out over here. There we go. And just for sanity's sake, I'm going to show you that nothing has changed. There we go. It still works. All I've done is just store it in a variable. Now, I know that all of these are numbers. So because this is my example. So I'm actually going to turn that into a number. I'm going to parse it. Integer.parseInt element. And let's just one more time print them all out, only now we're printing them as numbers. You can't tell that it's different, but it is. Now they are numbers. Okay, this is important, sort of, maybe. So what I'm going to do is I am going to say if my number modulus 2 is 0, meaning, if the number is even, I want to remove it. Now, do I remove it from my list or do I remove it from my iterator? Well, let's take a look and see what happens. If I try to remove it from my list, this is going to have to move though. Actually, I don't even want to print those for a minute. I'll just get rid of those. If I try to remove it from my list, let's just print our list down here at the end using our using our one print method, one line print. We already have the method. We might as well just use it. Compile and run. We get that same error. So it's still protecting us. We're going to break it. See that? We cannot do it just like we couldn't inside a for each loop. Now, iterators give us some extra power here, and iterators are a little bit magical. It's going to actually allow us to safely remove this element if we want to. We just can't do it this way. Instead, we're actually going to call on the iterator to remove an element, and we don't need to put anything in there because what this is actually going to do is remove the last element we nexted. So we just nexted this element right here, right? That's the one we parsed. That's the one we want to remove. So when we say it.remove, it actually will just remove it. Let's go ahead and run that and see what the heck is happening. All right. No error, and all of my even numbers have been removed. So I now have the safety of not messing up a for loop. I have the ease that comes with a for each loop, while still maintaining the ability to do things like conditional formatting based on where I am in the list and safe removal. So as we can see, the iterator is kind of the catch-all. It's a little bit overkill for a lot of the things that we do, but it is still worth showing to you because it's pretty powerful and there are a lot of really neat things that you can do with them, and they enhance our safety, and they are significantly more standard to be used like in the real world outside of, an academic setting, over like a for each loop, just because of the safety features that iterators have built into them. All right, we have now shown a few different ways that we can iterate or loop through our array lists. Depending on your needs and what you're using it for, these all have their value, and so they all exist for a reason, but knowing which one to use when is really important. We're going to finish off this topic in my next video where we discuss some common pitfalls and some concerns that occasionally come up when it comes to array lists, some of which we've already seen, so it might sort of just be a recap for you. I'll see you in that video, and thanks for watching.